This is separation by precipitation, version 2, and it's one with a lot of ions, 4 ions. So we have an acidic solution that is 5 millimolar in each of the following metal ions: barium, cadmium, iron, and manganese, all of them 2+. We're asked which of the metals would precipitate as their hydroxides at pH 8. Question B is for pH 10, and C asks, at what pH do the metal hydroxides begin to precipitate? Okay, I'm actually going to do this problem in reverse. I'm going to do C first. The reason being, once I answer C, it's very easy to do A and B. Alright? So, the way to approach this is to say Ksp of barium hydroxide is equal to the barium concentration times the hydroxide concentration squared. So, if I want the hydroxide concentration, I really need to take 5.0 times 10 to the minus 3 and divide it by the barium concentration, which is 5 times 10 to the minus 3 molar. That will equal my hydroxide concentration squared, so I need to take the square root of this. So, let me do that. It looks like I get 1. So, my hydroxide concentration is going to be equal to 1. I'm going to take the negative log of 1, which is going to give me my pOH, which is equal to 0. So I guess that gives me a pH of 14. So we'll write 14.0 for sig fig. Alright, next one. Once again, we will recognize that it's going to be equal to cadmium 2+ times hydroxide squared. So if I take 2.5 times 10 to the minus 14 and divide it by the cadmium concentration, I will get the hydroxide concentration squared. So I should take the square root, and punching that into my calculator, let's see, we've got 2.5 e to the minus 14 divided by 5 e to the minus 5. I get a hydroxide concentration equal to 2.236 times 10 to the minus 6th. I will take the negative log of the hydroxide. So let's see, that's log of this, and it comes out to be 5.65. So that means my pH is equal to the difference of that between 14. So that comes out to 8.35. Alright, very well. Next one, I think you can see the pattern here. Okay, I'm going to take 8 times 10 to the minus 16, divide it by 5 times 10 to the minus 3, take the square root thereof to get the hydroxide. It's very repetitive. So 8e to the minus 16 divided by 5e to the minus 3. I wind up getting 4.0 times 10 to the minus 7. I will take the negative log of the hydroxide, and that turns out to be 6.40, which means the pH is equal to 7.60. Okay. Last one. 1.9 times 10 to the minus 13 divided by 5 square root thereof is equal to my hydroxide concentration. Okay. And that comes out to be equal to 6.16 times 10 to the minus 6. Once again, the pOH is going to be equal to the negative log of that. So that turns out to be 5.21, which means the pH is equal to 8.35. 8.78. Alright, now as far as sig fig goes, I guess technically I should input these as 14.0, 8.4, 7.6, and 8.8. Okay, now let's talk about what these pHs mean, okay? Below the calculated pH, the whatever salt we have is soluble. Okay? Above whatever this calculated pH is when the salt that we have precipitates. Okay? So, for going back to question A, which of the metals would precipitate as their hydroxides at pH 8? Looks like we only have one, Fe2+, because it begins to precipitate at pH 7.6. Which of the metals would precipitate as their hydroxides at pH 10? Looks like we have three of them. We have iron, which has already precipitated, and then also cadmium and manganese. And it looks like it would be very difficult to precipitate barium hydroxide, at least at 5 millimolar concentrations, in water. Looks like it can't be done. Alright, that's all there is to that.